Hi, this is Mark Tory, President and CEO of Defence Metals. I'm just going to run through a presentation that I have given at a couple of conferences just in relation to what rare earths are all about and what you need to have a look at when you're evaluating specific rare earth element projects. Firstly, rare earths, there are a number of different elements in rare earths. What I'm going to focus on today is two elements, being neodymium and praseodymium. These are what's called magnetic rare earths, and these go into permanent magnets, and they have critical technology applications for everyone in all aspects of our lives. Permanent magnets go into automotive vehicles, into hybrids and electric vehicles. They go into catalytic converters. They also go into wind turbines for power generation and other power generators. One of the big growth areas in relation to rare earths is in robotics and electronics. But they're also in some of your everyday items, such as smartphones, batteries, hard drives, and computer screens. Some of the other uses outside of permanent magnets include in chemicals and catalysts. As you can see, it's in optical quality glass and air pollution control. It's also used in the medical industry for MRI scanners, CT scanners. It's also used in agriculture for farm equipment motors and fertilizers, and importantly as well in aerospace and defense. And that goes in, guidance equipment, thermal barrier coatings, submarines, plane motors, etc. So where are all the rare earth elements? China dominates the rare earth industry, specifically downstream industries. And we're seeing that there's a lot more search for rare earths globally, specifically in the Western world. As you can see from this graph, when you look at reserves of rare earths globally, China has 48% and the rest of the world has 51.6%. But as you move down the chain, looking at all the different processes in relation to mining, processing and refining, metal conversion, and then finally magnet making, you can see that China starts to dominate in relation to the amount that they have of the total industry, where by the time they get to making magnets, they're looking at greater than 90% of the magnet industry. And this is something that the Western world is focusing on at the moment in relation to trying to move away from that dominance of China so that there's not a reliance on supply from China. We can see that there's a growing supply side shortage, and this is shown through a number of different organizations who do demand supply analysis in relation to rare earths. And when you're specifically looking at NdPr supply demand, you can see from the graph that when you look at non-China balances, that we're definitely in the negative, and when the Western world's looking to try and get new ways to get rare earth supply where it's not coming out of China. At the moment, the current Chinese pricing is above the floor price which was given to MP Materials by the US government. This floor price was $110 per kilo for what's called NdPr oxides. But Chinese export restrictions create global shortages, and they move the price of NdPr oxide plus other rare earth oxides when they do put on these export restrictions. We've seen NdPr pricing peaking well above $200 a kilo. So I've been in the rare earth industry for over 12 years. And I guess this is my sort of Mark Tory 101 in looking at how do I analyze rare earth projects. And, the things that we've got to look at in relation to rare earths, they are complicated. And every rare earth project is actually unique. No one's exactly the same. And there's no magic formula there for a rare earth deposit to be mined and processed. Look, there's a high-level rare earth deposit analysis that we'll run through, and I'll give you some key identifiers that need to be looked at when you're analysing a rare earth project. So why are rare earth deposits different? Well, firstly, location. So, in relation to rare earth deposits, they can be found remotely. Generally, they're very, very remote. Luckily, some not so remote, such as the Wicheeda deposit itself with defence. You've got different types of deposits, such as a hard rock or a clay deposit. And then you have a different mix of what's called the basket of rare earths, and that can be differentiated into lights and heavies. And that's what we talk about in the basket of goods in the REE deposits. There's different mineralisation as well, such as bastonosite, monazite, xenotime. And again, when you look at those, that means different ways to actually process those mineralisations. And then you've also got differences in the host rock that the mineralisation is situated in. So what to look for when you're looking for a rare earth deposit and location? Obviously, you've got to look at infrastructure, you've got to look at power, got to look at availability of equipment and labour, you've got to have a look at external transport as well as internal transport. So what does that mean for us at Wicheeda? What are the location advantages in relation to the Wicheeda project? Wicheeda is positioned at the crossroad of opportunity and infrastructure. It is close to existing roads, rail, and availability of hydroelectric power, as well as a gas pipeline. It's located only 80 kilometres from Prince George, which is a service and supply centre for natural resources, construction and mining. There is an availability of a skilled workforce there. The port of Prince Rupert is 500 kilometres to the west and is accessible by both rail and road. The project itself is accessible through a major forestry service road that is connected to the major highway. So one of the things that we don't have, but clay deposits are important in relation to heavies in particular. So in southern China, there's a lot of heavy rare earths, such as dysprosium and terbium, that are produced out of southern China. And we're starting to see a few more projects coming out of the likes of Brazil, which have these ionic clay deposits. So what are the things to look for? And as I said, they're generally a mix of, DyTb, the heavies, as well as a lower percentage of neodymium and praseodymium. The one thing to look at when you're identifying ionic clay deposits is to ask, what percentage of TREO comes out via the ammonium or magnesium sulfate leach. And for strong projects, that amount is about 60 to 80% of extraction via a mild leach, and the weak projects have a low extraction rate and may require some acid baking or cracking. And when you have to do that, it really destroys the economics of the ionic clay models. The advantages of clay projects: it's very low mining costs, has no crushing or grinding, very simple leach and low capex. But the risks include the reagent consumption, which is very high, the impurity handling, very low recoveries, and a poor basket value. And these risks can completely offset the mining advantages. What we have at Wicheeda is a hard rock deposit. And so what do you look for when you're looking at a hard rock deposit? The main thing to look at is its ability to concentrate up through a beneficiation process, which allows for the economies of scale in a metallurgical processing. Now, when we talk about the deposit concentrating up through a beneficiation process, I will run through a slide shortly, but strong projects show that they have a 40 to 60% concentrate grade. Weak projects are lower concentrate grades and require a much larger hydromet facility. And when you're talking about processing of rare earths, it's the hydromet where there are the higher capex and opex costs. Therefore, the higher the concentrate grade, the smaller the hydromet plant, which means lower capex and opex costs. The advantages of good hard rock projects are the higher grades generally, and the established mining and beneficiation methods, and the transport of upgraded material, which is lower logistic costs and lower throughput. But obviously the risks can include mining costs, the impurity handling, metallurgy can be difficult, hydrometallurgical costs, and much higher capex. This slide here is what I tried to demonstrate in relation to why the concentrate grade is important. And the way that I've always looked at analysing projects is if a project can concentrate up to sort of greater than 30% in light rare earths and greater than 20% in heavies, they've got the opportunity to be an economic project. What this slide is supposed to represent is showing that a concentrate grade that is 3 times lower, so the 15% concentrate grade there after going through a beneficiation plant, compared to the 45% concentrate grade, shows that the 15% concentrate grade means a 3 times the size hydrometallurgical plant compared to the 45% TREO grade. And that both of those plants will give the same output. And that's, again, just due to the concentrate and the feed that needs to go in to get the same output. Wicheeda, so that's one of the reasons why I did move from Australia over to Vancouver to look after this project, is it concentrates up to a 50% concentrate grade. And that puts it in the same light as, the two major operating rare earth mines globally, being Lynas in Australia and MP Materials in the US. And you can see from the table here how competitive the Wicheeda project is in comparison to those, as well as the existing Chinese light rare earth projects that are there. And when you look at hydromet, one of the other things I've always said when I talk at conferences, etc., is that a hydromet does need to have economies of scale. It needs to be of a certain size for it to be economic. And to me, that size is around that output of around 5,000 tons of NdPr when you're looking at processing through the hydrometallurgical plant. And the reason for that is the reagent consumption, and the fixed costs versus the variable costs. And for me, from a Mark Tory point of view, I've always said that there should be 5 or 6 different hydrometallurgical hubs in the Western world, which can process different concentrates that come from various projects around the region. So looking at a couple in North America, you'd look at potentially one in Europe, and you've got 2 or 3 in Australia. And the benefits of having those economies of scale and have that bigger hydrometallurgy, you have much better efficiency, you have the lower unit costs, which makes it very, very competitive in the rare earth supply chain. So for Wicheeda and defence, what are our unique advantages when you compare it to all of these, and why am I here looking after Wicheeda project? Wicheeda is North America's and Europe's premier rare earths deposit. We have a high amount of neodymium and praseodymium located near Prince George, great location as I've run through, and it's a large proven reserve for potential long life mine and high grade rare earths at surface with a low strip ratio. Pre-feasibility study was completed in 2025, and that showed robust economics with high operating margins. We're looking for strategic partnerships globally. We've signed an MOU with Hanwha Ocean and Hanwha Corporation for potential offtake, technical and financial partnership. Also continuing to advance discussions with other potential strategic partners. And this is on an offtake side, as well as a technical side, as well as a financial side. And this includes private as well as government. Our current valuation offers significant potential upside. It's one of the lowest price to net asset value ratios in the industry. So it highlights a substantial opportunity for growth for the company. We've got strong leadership. We've got a great board and senior management with extensive experience in rare earths. And we have strong relationships with Western governments in Canada, the United States, and the European Union. The big thing to take away from here is that Wicheeda is the only undeveloped reserve in North America. And this indicates the robust project with lower risk, and only reserve level projects attract project debt. Thank you for your time.